I've got to make clear in this unit. Anytime you answer a probability question, it should always be a fraction less than 1. All right, meaning you will give me a fraction where the numerator, the top, is smaller than the denominator. All right, why do I tell you that? If I ask for what's the chance of rain today, you're going to give me 128%? Probably not. Right? Probability, answers in probability can never be bigger than 1. Okay, that's why I say when you give me an answer, it should be a fraction less than 1 where the top is smaller than the bottom. Second thing, never negative. Okay, always positive. What's the chance of rain? Negative 20%. What are you telling me? All right, you're laughing because it sounds ridiculous, because it is. All right, but keep that in mind. Anytime you answer a probability question for me, less than 1, never negative. Okay, less than 1, never negative. All right, you want to jump right into this bad boy here? We got a lot going on today. And the only reason I think this unit's tough for a lot of students, it's so darn wordy. All right, what I'm asking for is not bad. It's just reading through everything. So here we go. Some basic probability. You have a spinner divided into 6 slices, numbered 1 through 6. Okay, so if you ever need to, draw yourself a diagram, I don't need one or require one, but you got 1 through 6. I have no idea how that's. I'm not even going to bother because I'm going to embarrass myself. What's the probability that the spinner will land on a 4? All right, and I know some of you probably already know this and can answer this, but I'm going to take this as slow as I can here. First thing, notation. I'm not going to write out every single problem. Find the probability the spinner lands on the number 4. Here's what you're going to see for me. Capital P for probability, capital P for probability, and then inside is what I'm looking for. In this case, it lands on a 4. All right, get used to the notation because it's not going to be written out in words most of the time. So how do I determine the probability? On the bottom, in the denominator, goes all your possible choices you have. So this is a spinner labeled 1 through 6. How many choices do I have? 6, right? So 6 goes in the bottom. That's the total number of outcomes possible. On the top is how many fit what I'm asking for. How many 4s are there? 1/6. Okay, so the probability I land on a 4 is 1/6. On the bottom, again, total number of outcomes. On top, however many fit our description here. Any questions? That's about as basic as it comes before we get more advanced. Good? Anything? Seriously, ask away. Ask away. All right, let's keep rolling then. So let me put a not in front of it now. Same spinner, 6 slices. Find the probability the spinner does not land on a 4. Does not land on a 4. So again, P for probability. And inside what I want, not a 4. All right, in your denominator, how many choices do you still have? 6. We're all good there. Now, how many are not a 4? 5 out of those 6. So my probability is a 5 out of 6 chance. Less than 1, right? That's what we want every time. All good? All right, now it gets a little nuts here. So on one spin, what's the probability the spinner lands on a number greater than 3 and it's even? Okay, lands on a 3 and it's even. Here, I'm going to give you a shortcut here in a second, but here's where it might be a good idea, especially the first couple, to write it out here. And what I mean by write it out is, all right, look, 1, 2, 3, 4, 5, 6. Those are my choices on the spinner, right? All right, go through with me. I'm going to go through each option. You tell me if it's good or not, greater than 3 and even. Is 1 going to count? Nope. 2? 2? What's wrong with it? Okay, it is even, but not greater than 3. 3? 4? 5? 6. Okay, so what did we find out? 2 choices out of how many options again? 6. And for me in this unit, just so you know, I don't care if you reduce or not. The only thing I warn you about, if you're doing a multiple choice question, the answers may be reduced. Okay, so 2/6 or 1/3. Let me show you the shortcut now. Let me show you the shortcut, because sometimes listing them out might take a while. So let me show you a little shortcut. Anytime it's an and, you have the word and in there. You want to multiply. Multiply what? Take a look. Each of them separately. So ready? Greater than 3. What would be your probability of picking a number greater than 3? 3 out of 6 or a half. Sure. Yep. 1, 2, 3. Half, even. 1, 2. Actually, never mind. We're not ready. I'm not. Sorry. I'm getting ahead of myself. All right. My fault. So 1 out of 3. Everyone good? I'll just keep it at that. I don't want to get too crazy. All right. Probability of an or. Watch what happens here. All right. Or is where you got to really lock in. Probability of even or greater than 3. All right. Let's do it again. 1, 2, 3, 4, 5, 6. So it can be one or the other now. Ready? Would I count 1? Would 1 count? Nope, it's not even or greater than 3. Can I count 2 now? Yeah. Whoa. Even or. I didn't put an and here. It's different. Even or greater than 3. Can I count 2? Why? Because it can be even or it can be greater than 3. 2 counts. How about 3? Does that count? No. How about 4? Does 4 count? Okay, now we got to start watching ourselves. Is it even? Is it greater than 3? Okay, but I can't count it twice. All right, I can't count it because it's even or greater. I can't count it twice. It's only going to be counted once. You see what I mean by it can't be counted twice? Don't count it because it's even, and also count it because it's greater than 3. It only can be counted once. 5 work?
Yeah. Oh, yes.
Why? Right, the or is, you got to watch out for the wording. The or means it could be this or it could be that. So 5 does work. And what about 6? Yes, but I'm only counting it once. So how many choices do I have here? 4 out of 6. Or if you want to write 2/3, that's fine with me. Ooh, you ready for this next one? All right, you might be with me so far, and I don't want to lose you on this one. Probability of getting a number greater than 3, given it's already landed on an even number. Okay? So first, notation. Greater than 3. Now take a look. You're going to start seeing this vertical bar there. Hold on, Harper, let me talk. All right, you're going to start seeing this vertical bar here. This vertical bar, where did it go? Is symbolically for given. All right, that's what we put for given. We put that bar there. And then even. Go ahead, Harper.
Do we have to do the notation on the text? Is that required?
No, but you should, if I write it like this, you should know what's going on.
Yeah, I just mean like if we get a word.
No, I don't expect that, but my questions are probably going to already be in notation form. Okay? All right, here you go. Watch what happens now. Watch what changes. Getting a number greater than 3, given, what do we already know? It's landed on an even number. It's already landed on an even number. So watch. We do not have 6 choices anymore because we already know it landed on an even number. How many choices do we have now?
3.
Great job. We have now 3. So this is going to be something out of 3, not out of 6. So when you're given something happen, expect a new denominator. All right, so we do not have these choices. We do not have 1, we do not have 2, we do not have 5. Does everyone see why I'm putting in a denominator of 3? We are already given it's an even number. All right, so how out of these 3, how many are greater than 3?
2.
2 out of 3. So please watch out when they it's a given problem. Okay, because your denominator is not going to be what it's used to. Does everyone see why it's 3? We already knew it was even, so instead of 6 choices, now it's down to 3. Good. We're all right. Let me know. Okay. All right, let's put it all together now. I flip a coin and I roll a 6-sided die. Below, given the symbolic form, write out what it means in words and then find the probability. I think right now we're comfortable with writing out all the possibilities. All right, I think that might help us. We'll see here. All right, so what's my possibility of tossing a coin? Heads or tails, and then a 6-sided die would be 1 through 6. So basically, if I'm writing this all out, I could go H1, heads 1. I could also go tails 1, right? And then what else do I have now? 1, 2, 3, 4, 5, 6 with heads and tails, right? My worry is, and I don't think it'll come up yet, is when there's just too many to list out. How many options do I have? 12. So all my denominators should be 12 unless it's a given problem. Okay, all my denominators should be 12. All right, what's this telling me? We got to write this out in words now. Probability of, what do you think H means? Heads. So probability of heads. Does it matter what I get on the die? Nope, didn't say. I just want a head. That's it. Probability of heads. Okay, how many you got?
6.
6, right? 1, 2, 3, 4, 5, 6 out of. What was our total choices again?
12.
Okay, and if you want to leave that 1/2, that's fine with me. Okay, probability of tails and a 2. So we see the word and, which means both have to happen. Both have to happen. So how many times does that occur? You get a tail and a 2.
1 time at a time.
Tail and a 2. Both have to happen together. It's the only time I see it happening together. Once out of 12 times. Oh, sorry. Thank you, Paige. Sorry. Probability of tails and a 2. Okay, now it's going to be a little different, right? Probability of a tail or a 2. Okay, now be careful. Don't count anything twice, right? Don't count anything twice. Get rid of that. Okay, how many are going to happen? I don't want to go through all of them with you. Let's count them up. It can be a tail or a 2. So basically, hey, all of those count, don't they? And then over here, how many?
1.
And again, do not count that twice. I can only count it once. So I have, 7 out of 12. All right. Losing anybody yet? Okay, next one. Sorry, I couldn't get a vertical bar, but probability of what? Tails. And how do I read that vertical bar? Given it's already a what? Given it's already a 2. So now my outcomes aren't 12 anymore, right? We already know a 2 has landed. So instead of 12, how many outcomes do I have? Ooh, instead of 12 outcomes, we already know a 2 has landed. It's down to these two. So it's something out of 2. And how many are tails? There it is. Okay, please watch out for the given ones. Good, Grant? Because I know this is probably the newer stuff here with the given. All right, and then let's flip it. Probability of 2 given tails. Not 12 outcomes anymore. You already know tails happen, which is how many?
6.
Good. Now it's going to be at a 6. So now just focus on those 6. Nothing else. Focus on these 6. How many are a 2? There you go. Anything before we change it up? Going? All right, now it's reading from a table. Okay, reading from a table. First thing, I need your help filling in the rest of the table. All right, I can't do much until it's all completed. So can you guys help me out with the totals here? Let's go total amount of people over 5 feet. Total amount of people over 5 feet? 67. Okay, let's go. How many people are over 14 years old? 70. And this is how you know you've done you filled in the chart correctly. No matter how you add them, the total overall should always be the same. And what's that 100 going to be now? It's our denominator, right? That's going to be our denominator unless it's a given problem. All right, let's see what you got. What's the probability the person will both be under 14 years old and 5 feet tall? I got the and there. So both of those have to happen. So now I got to look at the table and say, all right, under 14 and over 5 feet tall. Kind of looking for the intersection there, right? Because they both have to happen at the same time. So under 14, over 5 feet, how many you got? Oh, sorry, under, my fault. Under 14 and over 5 feet. 9 out of, there you go. I don't need to do any notation here. We'll just keep it the answer. Probability that a randomly chosen person will be under 14 years old.
30.
Did I give any? I just said what? Under 14.
30.
And we said there's a total of 30 of them. If you want to put 3/10, that's fine. Okay, here we go. A randomly chosen person is over 5 feet or 14 years old. We got to watch ourselves here. Let's take it one by one. How many are over 5 feet? 67, yep. Plus, how many are over 14 years old? Hold on. I'll explain everything here. So everyone's good. Over 5 feet, 67. How many are over 14 years old? 70. But I got a problem. Well, first problem's going to be when you add these two bad boys up, 137 of 100. What the heck did we talk about first thing today? Can't be over 1. So something went wrong there. And what went wrong? We did everything we asked. I counted people twice. Right? I counted people twice. There's people that were 5 feet and 14 years old. Over 14, I counted them twice. So what I need to do is subtract out the number of people that are both. Because everyone understand why I counted them twice. I counted them because they were over 5 feet, and then a second time because they were over 14.
So you just subtract.
I subtract out what's in common now.
50.
So over 5 feet, 14 years old, I counted 58 people twice. So I have to subtract out that 58. And even if you did forget, right, that number was over 100, and that cannot happen. Cannot happen. So in total, I have, what is that, 79? Right? Am I just going to leave it 79? Over 100. Alrighty. Let's get crazy. So, and also, are we okay with that? Again, the only time you need to worry about counting people or counting anything twice is with the or. Okay, that's the only time you need to worry about counting things twice is with it. And don't even have to worry about it. It's the or. All right, let's see who's on point here. You choose a person over 5 feet tall, given the person's already over 14 years old. So this is not out of 100 anymore. Because what are we doing? We already know that the person is over 14 years old. So we are only focused on this column right here. Correct. That column. Because we already know they're over 14. So we're saying out of those 70, not 100, out of those 70, how many are over 5 feet? And if you read the table, how many are over 5 feet? 58 of them. So if it's a given problem, be ready for it to be a different denominator than the total. Guys, anything I can answer? We got one more type of question. This is through a table. Last thing I just want to do is a Venn diagram. All right, Venn diagram. I just want to make sure we know what the different parts are, because I'm never a fan of a Venn diagram, but the 33 in the middle. So those are 33 people. I don't know why, but 33 people that like mustard and yogurt. Okay. What's the 87? Just like yogurt only, right? 22?
Just like mustard.
Good. And then what about this 58 hanging outside?
Who don't like either.
Yes, correct. They don't like mustard or yogurt. All right. So first thing we should probably do is how many people total are we talking about? Right? How many people total are we talking about so far? So the 87 yogurt, the 33 that like both, the 22 that like mustard only, and the 58 that don't care for either. 200 people. Good, because that 200 is going to become our denominator. All right. Probability, they like frozen yogurt but do not like mustard. And that's where on my Venn diagram. That is 87 out of the 100. 200, that would work too. Probability, they like mustard. Be careful here, they like mustard.
55.
I just see 22. What am I missing? Oh, it just says mustard. It doesn't say mustard only. It just says likes mustard. So you can like mustard only or like both. You still like mustard, right? If you like mustard and yogurt. So I got to include that 33. So we 55 out of 200. All right, watch your mouth here. Watch your mouth. Given that they like mustard already. So this ain't going to be out of 200, is it? How many like mustard?
55.
How many like mustard?
55.
What's the probability they also like frozen yogurt? So now we're just looking at those two. So out of those 55, 33 of them also like frozen yogurt. Right? I think that's ball game, right? Okay. Please look up the answer key as you will go along. Call me over. This is like half the class now we get to practice.